Greetings. Today I, Deeti Verma, and my project partner Viren Ranglani, final year B.Tech students of Civil Engineering, will be discussing about our major project, BIM application for MEPF design of a commercial building carried out under the guidance of Dr. Shobhit Chaturvedi. Initially, we have to model HVAC design, which is the first part of our project. We need to choose a suitable template in Revit, for which we choose system default. Now the first step is to analyze and create different spaces and zones according to the different heating and cooling requirements for an HVAC model. For that, first we go into second, for example, here I'll go into second floor level ceiling plan. Spaces are created on ceiling plans. So for that, I'll go into Analyze tab and then select spaces and then allocate different spaces. As you can see, we have already allocated spaces over here according to our requirements. The similar thing is to be done for creating zones, but that will be done on floor plans. So I'll go into second floor level, then select zones and analyze tab, and then again allocate different zones and then click finish. Okay. Now the next important step is to calculate heating and cooling loads, for which again in analyze tab there is an icon representing heating and cooling loads. As this window loads, I'll just explain it to you in brief. First we need to add the general details. For example, this is a commercial building, G+6 commercial building. So we have added building type as office, the location, and the building phase and everything. The tab beside it, that is details. We have different zones that we have created. For example, office 1. Here we need to add space type, construction type, etc. Save settings and calculate. So here's an already generated load report. We'll get this load report, which includes building summary, project summary, and different zone summaries with respect to the HVAC parameters. For example, as office 1, the area, volume, peak cooling load, airflow, peak heating load, heating airflow, etc. have been calculated. Now again, the next step will be to calculate CFM, that is cubic feet per minute, for which we'll go into View tab, Schedules and Quantities, select Mechanical. Then in the categories, go to Spaces, name it HVAC space schedule. Click OK. Then we'll get this window in which we'll create a formula for calculating CFM. CFM is calculated as calculated supply airflow minus actual supply airflow. After doing that, we'll get this report generated by Revit. I'll just scroll up to show the headings. Wait. HVAC space schedule, name, calculated supply, actual supply, and difference. So the next step is, after all of this is done, we'll incorporate the main equipments. Okay, for that we'll go into System tab, Mechanical Equipments. So the three mechanical equipments we'll be adding are AHU, that is air handling unit, VAV, and chiller. Chiller is used for example, this portion over here. This component is known as chiller. Chiller is basically for air conditioning purposes. And for example, and then we'll add AHU and VAV as well. After that, air terminals need to be added. There are three categories. The blue air terminals represent supply diffuser. The pink air terminals represent return diffuser, and the green ones represent exhaust grills. Now these air terminals are again added from System tabs in Air Terminals, right beside Flex tab. Okay, after we have added these air terminals, then what we need to do is provide proper ducting. Now, for example, ducting will be provided in order to connect system and return diffusers to VAVs, etc. So again, in System tabs we have ducts. Let me me just delete one duct over here. Let me just delete this duct over here. Now in system tabs, I'll choose ducts and then draw a duct connecting these two. All the similar thing has been done for all of these ducts. Then flex duct has also been used in order to draw ducts or model ducts, for example over here. So now an important element in this is duct sizing. I'll select a duct over here, for example. As you can see, we have duct sizing and system inspector. I'll go into system inspector, inspect. Now as you can see, the airflow has been clearly displayed with the help of arrows, and the different flow values in terms of CFM have also been displayed. Accordingly, as you can see, as the CFM value decreases, the duct size is also decreasing. Revit has this feature of system inspector because of which we can automatically properly size the ducts. And yes, now I'll go to the 3. After modeling ducts and connecting AHU, VAV and chiller as well, our entire HVAC model is ready. As you can see, this is the final model. And with that, Alan, thank you so much for watching this video.